We spend so much of our lives on the web, and a lot of the time, it just feels like magic. It's fast, it's personal, and somehow it seems to remember us. Today, we're going to take a quiet look under the hood at one of the engines that makes all of that possible. I mean, really think about that for a second. You add something to your cart, you click over to another page, maybe you read some reviews, and when you come back, it's still there, just waiting for you. How does that even happen? It seems so simple, but it's actually solving a huge, fundamental challenge in the way the web was originally built. And to really appreciate the solution, we first have to understand the problem it was trying to solve. See, the smooth, seamless web we know today didn't just pop into existence, it evolved. And in the very beginning, making a website do anything more than just show you static text was, well, it was a bit clunky. So the first real attempt at making web pages dynamic was this technology called CGI, which stands for Common Gateway Interface. It was basically a way for a web server to run a little program to generate a custom page just for you. It was a step in the right direction, for sure, but it had one major drawback. And this is the absolute core of the problem. Imagine a restaurant. With CGI, it was like every single time a customer placed an order, the restaurant had to build an entirely new kitchen from scratch, cook that one meal, and then tear the whole kitchen down again. I mean, you can just imagine how incredibly slow and wasteful that is. It just doesn't scale at all. So, yeah, people needed a better way, a much more efficient model, something that could handle tons of requests without just completely falling over. And that elegant solution was the Java servlet.
So what is a servlet? Well, in the simplest terms, it's a piece of Java code that just lives on the server, always on and ready to handle requests. Let's go back to our restaurant metaphor. If CGI was building a new kitchen for every order, a servlet is like a highly trained chef who stays in one permanent, fully equipped kitchen, ready to handle any order that comes through the door. So much more efficient, right? And this new approach came with some huge advantages. Because servlets are written in Java, they can run pretty much anywhere. They're also incredibly efficient, handling lots of requests at once inside a single process. And they're built to scale, all the way from a single laptop to a massive cluster of servers. So how exactly did they pull off this efficiency? Well, the secret is in their very simple 3-part lifecycle. You can think of it as a day in the life of our super efficient chef. Okay, so it all starts with the init method. This is when the servlet is first hired, and our chef sets up the kitchen for the day. This only happens one time, right when the application starts up. Then you have the service method. This is the real workhorse. This is the chef cooking, and it gets called over and over and over again for every single request from a user. And finally, way at the end, when the whole web application is shutting down, the destroy method gets called. This also happens just once, to clean everything up as our chef retires for the night. And you can really see that flow here. The init part happens once at the beginning. Destroy happens once at the very end. But that middle loop, the service method, that's where the servlet spends all its time, just efficiently handling one request after another without all that expensive setup and teardown every single time. And here's the crucial part to remember. The server only creates one instance of that servlet, just one chef in the kitchen. But that one chef is an amazing multitasker. They handle tons of orders at the same time, using something called threads. You can almost think of threads as extra pairs of hands. Each request gets its own pair of hands, but it's all still being handled by that same single chef. And that is the secret to its incredible performance.
All right, so we've established that servlets are fast and efficient. Now, let's circle all the way back to our original question. How does this technology solve that shopping cart problem and basically give the web a memory? See, the basic language of the web, HTTP, is what we call stateless. All that means is that every single request you make to a server is treated like a brand new event. The server has no built-in memory of who you are or what you clicked on before. So without some help, it would forget what's in your cart the instant you clicked on a new page. The solution is this neat idea called session tracking. And the best way to think about it is like this. When you first visit a website, the server gives you a key to a temporary personal locker. This locker is called an HTTP session object, and you can store your stuff, like the items in your shopping cart, in this locker while you browse. So that key to your personal locker is just a unique session ID. With every single click you make, your browser shows this key to the server. The server uses that ID to find your specific locker, see what's inside, and keep your experience personal. And just like that, a stateless web can have a stateful, continuous conversation with you, Pretty cool, huh? Now, I know what you might be thinking. Modern web development has all these fancy frameworks and technologies, but the fundamental ideas that servlets introduced, they are still very, very much alive. They're really the foundation for a lot of the logic that powers the modern web. So what's the big takeaway here? Really, it's that servlets were this quiet engine that solved one of the web's biggest early problems. How do you have a real conversation on a platform that's fundamentally forgetful? And even if developers don't write the word servlet in their code every day anymore, the principles they established of an efficient, stateful server are exactly what makes our digital world feel so connected and personal today. When you zoom out, the story of the servlet isn't just about code or servers. It's really a beautiful example of how progress so often comes from just finding simpler, more elegant ways to have a conversation. In this case, a conversation between your browser and a server that could be halfway across the world.